equals negative. One more example, and this time it's a system of 3 equations and 3 variables, but there are missing terms. There's not an x and a y and a z in every equation. So we have to get a little tricky. Here's our system. It's 2x plus y. Notice I have an x and a y in the first one. In the second equation, I have a y and a z. In the third equation, I have an x and a z. Since I have an equation where the coefficient of one of the variables is 1, I'm going to use substitution. Don't have to do that. We could have used elimination, but in this case, substitution, I think, is the easier way to do it. I could have, for example, combined the first and the second to eliminate the y value. And if I had eliminated the y variable, I would have been left with an x and a z, and I could have combined it with the third equation. But that's not what I chose to do. So what I'm going to do is use the substitution method on the first equation and get 2x plus y equals 6, or y equals negative 2x plus 6. Now I'm going to take y equals negative 2x plus 6, plug it into the second equation, and solve it for z. So that gives me 3y minus 2z equals negative 4, and now I'm going to substitute the y with negative 2x plus 6 right here. I will distribute, giving me negative 6x plus 18 minus 2z equals negative 4. And I'm going to simplify a little bit to get, by subtracting 18, I'm going to get negative 6x minus 2z equals negative 22. And now I'm going to combine that with the third equation. And I'm going to solve the third equation. Solve the system of the second and third equations for x and y, which we've already done half a dozen times already in just the past few minutes. So notice my variable x has a coefficient of negative 6. In the third equation, my variable x has a coefficient of 3. So I'm going to multiply the third equation by 2 to get 2 times 3x is 6x. 2 times negative 5z is negative 10z, and 2 times negative 7 is negative 14. Now when I add these together, the x goes away. I've eliminated it, giving me negative 12z equals negative 36. Divide both sides by negative 12, and I get z equals 3. Then I just need to find y, which we can do by plugging it into, or did I find x first? No, I found y. So I got 3y minus 2z equals negative 4, and I plugged the 3 in for the z. That gave me 3y minus 6 equals negative 4. 3y equals 2 when I add 6 to both sides, and I get a fraction. I got a fraction as an answer, but that I can't help it. What I then did to find my x value is I took z equals 3 and plugged it into the third equation to find x. So I've got 3x minus 5 times 3 equals negative 7. C, I took the 3 and plugged it in for z. So that's 3x minus 15. When I add 15 to both sides, I get 3x equals 8, 15 minus 7. And my x value is x equals 8/3, giving me a solution. I've got my z value, I've got my y value, I've got my x value. So my solution to the system is 8/3, 2/3, and 3. And that is how you solve a system of 3 equations and 3 variables when you're missing some terms. And we've done a handful of solving systems, and I think that we are in good shape with that. So good luck.